angles to remind you what we did, okay? Then we're going to go through and do the reference angles and remind ourselves what we did. Then we'll talk about coterminals. So 60 degrees, it's in degrees, so this has to be in degrees. If this is in radians, then this would have to be in radians, correct? I can't just convert it and then choose to do degrees if it was radians. So this is where 0 degrees is. This is 90 degrees, 180 degrees, 270 degrees, 360 degrees, and I could keep going. Remember that we talked about positive angles went counterclockwise, negative angles went clockwise, right? That was one of the biggest things we talked about on that Friday. And then we have to go 60. So we have our rotation, which is about the center. Come on, join. It's supposed to be blue. Okay. So we rotate around the center. We put our initial arm. Our terminal's at 60. Thank you for turning back to whatever. And then I would go arrow up to it to show that I'm going in that direction, correct? And I would put it 60 degrees. Remember we talked about reference angles. Reference angles are the bow tie angles. They're the angles between the terminating arm and the x-axis. Reference angles are always positive because they're acute angles between 0 and 90. So if I had it here, here would be my reference angle. If I had it terminating here, this would be my reference angle. If I had it terminating here, this would be my reference angle. Here, this would be my reference angle, correct? Those little bow tie angles between the terminating arm and the x-axis. So if this is in quadrant 1, and quadrant 1's angle is 60, what's my reference angle? 60. Quadrant 1 angle, reference angle are always the same, right? Because it's the angle from the x-axis to the terminating arm, which is what that angle is. So we have a reference angle equal to 60 degrees. Then I said, okay, 5 pi over 3 might not be right now in your head knowing what that is. So for now, you might have to convert a lot of these into degrees so that you can draw them. So if I want this in degrees, I'm going to have to multiply by 180 degrees. So I get a degree symbol up top over pi. My pi is canceled off. What's 5 times 180 divided by 3? 300 degrees, correct? Now, I know that this is 300 degrees, and that is lovely, that I like degrees better than radians. That's cool. But you have to still do everything in radians. All right? So my x-axis has to be in radians. So this is 0 radians. This is pi, because 180 is pi, correct? This is pi over 2. It's half of pi. This one is 3 pi over 2. If you will have these memorized very soon. 270 is 3 pi over 2 because you could take 270 and convert it. It would come out as 3 pi over 2. And then once again, 360 is 2 pi. So I still have to label my axes in radians, even though I like degrees better, because the question was in radians. Now I can draw where 300 degrees would be. I start with my initial arm on the x-axis always. 300 would be 60 less than 360, so it's going to be about here. I draw counterclockwise with my arm to go to here, and I do not put 300 degrees here. What do I put? 5 pi over 3. Now guys, what would my reference angle be? If this is 300 to get me here, what would it be to get me from here to here? 60. So that's still a 60 degree reference angle. 60 converted to radians is pi over 3. I'm going to tell you one amazing thing about radians, because a lot of people can't find anything positive. The best thing about radians is the reference angle is pi over the denominator. So if this is 5 pi over 3, the reference angle is pi over 3. If it was like 5 pi over 7, it would be pi over 7. Works out every time. Here's your high positive of radians. If not, you could say, okay, well, this is 60 degrees, right? Converted as pi over 3. Or you could go 2 pi minus 5 pi over 3, which is still pi over 3. But it's always pi over whatever the heck the denominator was. All right. Then we go to here, negative 2 pi over 3. I can convert that if I want to as well. 180 divided by pi. Pi's cancel off. I get negative 120 degrees. Okay. The question was in radians, though, yes? So my axis needs to be in radians. So I'm going to go 0, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi. And then negative 120 would be 60 back from 180, so it'd be about here. And then I go negative 120 degrees. Is that what I do? Do I go negative 120 degrees? What was the question? Negative 2 pi over 3. I have to use what I have. So what's the reference angle? Pi over 3. So we draw 300 like you did before, 0, 90. You should have these already drawn on because we did these on that Friday, 270, 360, but I'm reminding you because it's been a tick. So 300 is 60 less than 360, so it's about here. Draw it around, right, 300. What's my reference angle? From that terminating arm to the x-axis, what's my reference angle? 60, because it takes me, if this is 300, it'll take me 60 to get to the x-axis. So I have a reference angle. Always positive, your reference angle. Negative 135, so I go 0, I go negative 90 degrees, negative 180 degrees. Make sure you have degree symbols. Negative 270 degrees, negative 360 degrees. 135 is directly in the middle. So here, here, oops. Rotating clockwise because it's negative. How far away is this from the x-axis? How far is 135 from the x-axis? 45, because you can just go 180 minus 135, correct? So this in here, this here, is 45, correct? That's the bow tie angle, yes? And the bow tie angles are the reference angle. So we have a reference angle of 45 degrees. And then 750 is 0, 90, 180, 270, 360, 450, 540, 630, 720, and then 30 more, correct? So I go start here at my initial arm, and I go 0 to 360, back around to 720, and then an extra 30. So 720 degrees. What is my, 750, don't know why I wrote 720. What is my reference angle? 30, because it's from the terminating arm to the x-axis. My reference angle is 30. Okay, everyone put their pencils down. We're going to make the next thing make sense. So it's not memorization, but understanding. Remember, memorizing scares me. Understanding makes it better. All right. So, say I give you the angle 120 degrees. You're not writing this, you're just paying attention. You don't even need a pencil in your hand. Okay? We're going to come back and do all of this on those other examples. But right now, we're just learning. So at 120 degrees, remember how we talked about coterminal? Coterminal angles terminate on the exact same arm, correct? Mm-hmm. So, if I drew 120 degrees, 0, 90, 180, 270 degrees, 360 degrees, and I drew 120. Cool, it's not blue anymore. So 120 is 60 shy of 180. So this is 120 degrees. I want you to discuss amongst yourselves another positive angle that would land on that, and another negative angle that would land on that. Discuss, see what you could do. Try and come up with some way, we've talked about it, that you could do. So, what would I do degree-wise to land on the same spot? To go a full circle? What would I have to do? 360. A full circle is 360 degrees, correct? So you could have went, and you're not writing this down, we're just discussing it, 120 degrees plus 360 degrees, and you get 480 degrees. Okay? So I've listed all the positive coterminal angles that exist in the world. Is that true? Have I listed all the positives? No, I listed the second positive. What could I do to get the third one? add 360 to the previous answer, or add 720 to the first question, right? Because 720 is 2 circles. Yeah? So if I want to go in the reverse, what would I do? 120 degrees, what? Minus 360, and I would get negative 240 degrees. And then I could subtract 360 again, which would be negative 720 from the original, right? And negative 1080. Do we agree on that? Okay, I need everyone's attention because this for general terms going to come in and you guys are all going to be in trouble if you don't pay attention right now. General term is a really easy concept if you understand why. If you're one of those people who tries to just memorize that it's like this all the time, not going to work out well for you in the end when we have to do solutions, okay? Because they aren't always like this. You understand why we do what we do and why we write what we write, okay? A general solution is ultimately if I don't give you a restricted domain, so like for this one, let's say I gave you the domain, I want all the coterminals between negative 360 and 720, you would give me this one, and the 120, right? Like those would be all the answers. If I gave you a restricted domain, you'd stop somewhere. But if I don't give you a restricted domain, there's an infinite number of coterminal angles in the world, correct? And how the heck would we answer all those? We'd have to keep going on for life, and we could. If you just keep going on, you wouldn't sleep, you just keep writing more and more and more. That would be terrible. So there's something called a general term for it, so that we can list all the coterminals that could possibly exist. How do they do that? Well, they go theta equals, and they go the principal angle. The principal angle is the angle between 0 and 360, okay? So had I not given you 120, had I given you 480, you would have to subtract 360 off of it to get 120 to use that. So our first angle has to be the principal angle between 0 and 360. I happen to give you the principal angle, which was 120, okay? So we're going to go theta, because that just means the angle equals, and we would put 120 degrees. I don't want you writing anything down. We are just understanding what we're writing. If we understand, we will do way better than memorize. Yeah? Because then you can't make mistakes if you understand. What did you tell me we have to do in order to get the next coterminal positive? Plus 360. Plus 360, plus 360, plus 360, plus 360. We agree? Okay. What do you have to do to get the next coterminal negative? Minus 360, minus 360, minus 360. Now what they used to do in the past, everyone paying attention, what they used to do in the past is they used to put plus or minus. They never use a plus or minus sign now. They always just go plus. Okay? We need to go 360 to the next one. Yes? 360 degrees times n. N is a number that we're going to fill in different numbers for to get the next coterminals. Okay? So what could n be in order to get the next coterminal angle? What would I have to put in for n? 2. Because that would give me 720 plus 120, correct? Okay. If I want the very next coterminal, I would just put a 1, because 360 times 1 would just add 360. The coterminal with its original self, I could put 0, yeah? Because 0 times 360 would just squash that, and I'd get the principal angle, which is 120, right? I could also do 3, I could do 4, I could do 5, I could do 6, I could do blah, 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 blah. Could I do decimals? No. Would a decimal work? Like 1.5? 1.5 would be 360 plus a half of that. Would that land on the same spot? If I went 360 plus a 180? No, it wouldn't land at the same spot. It would land at 1.5 times that spot. So it can't be decimals. What else could it be? How the heck could I subtract, though? It's a plus sign. Yeah? Make your number negative. Negative 1 would make me do 360 times negative 1, which is what? Subtracting 360, correct? So what else could I use? Negative 2 would rotate me negative 720 off of it, right? Negative 3, etc. Does that make sense, what we're doing when we put times by 0, 1, 2, 3? So we're saying n can only be these numbers. Is that what we're saying? What are those numbers in the number system? Integers. So a lot of people want to say n such that n is an element of the reals because you've done that in everything in life. N is an element of the reals means every decimal would exist. So you get like every little tiny decimal degree between 120 and like the world. Correct? That's not what we want. We want coterminals. We want to add 360s to it. So we need n to be an element of the integers. 0, 1, 2, 3, 4. Does that make sense? Yeah. Okay. That's if it's degrees. What if I give you 2 pi over 3? I want you, first off, 2 pi over 3 is 120 degrees. Just using the same thing in radians. Okay? So I would draw it in the same spot. Cool, cool, cool. How could I get the next coterminal without converting it to degrees, adding 360, then converting it back to radians? Because trust me, that is not fast. What'd you say? Adding 2 pi. If I add 2 pi, why am I not adding 360 degrees, Peyton? Right, and it's in what? Right, so we have to add radians to it, right? 2 pi is 360 degrees in radians. Okay? So we're adding 2 pi. So we need to make a common denominator. So I'm going to have to multiply this one by 3. So I'm going to get 2 pi over 3 plus 6 pi over 3, which equals 8 pi over 3. So that'll be my next coterminal. We agree? How could I get the first negative? What would I do? Subtract 2 pi. 2 pi over 3 minus 2 pi. Once again, make a common denominator. So I would get 2 pi over 3 minus 6 pi over 3, which is now negative 4 pi over 3. How do I do the general solution? You don't have to write this because we're going to work on this in the next page. How do I do the general solution now? 2 pi over 3 is my principal, so I need to start with that. Plus 2 pi n, and now what they'll do sometimes, because teachers, I don't know, switch the order, they'll go plus 2n pi, NEI, and then you guys are like, it's wrong. Can they put this out of order? It's multiplication, right? They can write it in any order. They could go pi n2. I hope to goodness they never do that, but they could, because it's multiplication, right? 4 times 3 times 2, 2 times 3 times 4, same answer. Yeah? Okay. So what I want you guys to do on this page is I want you to give me 2 coterminal angles. One up, one down for all of these. A, B, C, D, E, F. Go. So this one we're going to go 60 degrees plus 360, and we get what? 420 degrees. And then we do 60 minus 360, and we get negative 300. And then we just randomly write them down there, and then Mrs. Lepp knows I found the coterminals because she has to figure out the effort that those would actually be coterminals. Would that be a good idea? Or should we maybe label it? Oh, no, don't send it. Coterminal angles. So there's something there, right? Okay, I'm going to go down to this one. Negative 2 pi over 3. I could add 2 pi, which is negative 2 pi over 3, plus 6 pi over 3, which is 4 pi over 3. Or I could go 2 pi over 3 minus 2 pi, which is negative 2 pi over 3 minus 6 pi over 3, which is negative 8 pi over 3. And I really appreciate when people give me coterminal angels. They're my favorite. We'll swap the E's and the L's. I have a good giggle. If you did it on the diploma, we'll all just laugh at you, but we won't mark you wrong. If you give us coterminal angels instead of coterminal angles. We have a giggle, we show everyone, and then we still mark it here. It's the small joys you get when marking diplomas. Okay. So you understand what you would do for all of these, right?
Do you think they'll give me a mark if I draw like a really cool picture?
No.
What if I write a funny joke?
We'll laugh, we'll share it around, you'll still get a 0. We'll be like, oh, this is so sad, this kid's still getting a 0, but that was really funny. Yeah. All right, we have a rubric, we can't change it. So, what I want to sit on more is the general term one. So, remember, guys, for general term, you need a principal angle. So you need the angle between 0 and 360 or 0 and 2 pi, correct? So if I did not give that to you, you have to find it first. So let's look at A. A is 60 degrees. Is that my principal angle? Is that between 0 and 360? Yes. So we're going to go theta equals 60 degrees. Then what do I do to get to the next one? Plus what? 360 degrees what? N. And what does N have to be in order for this to not get me weird numbers and give me actually coterminals? Element of the integers. Okay? The general term should not be what is the hard part. Okay? If you understand why you're doing what you're doing. And you're not being like, is it real? Is it integers? Is it whole numbers? It's integers because it needs to be positive and negative and 0, right? Multiplying that 360, because it'd be 360 then times 2, 720 times 3, 1080, right? You don't want 2.5 because then it's going to go around twice and then a half. That's not going to land on the same arm at all. Okay? Let's look at B. B is 5 pi over 3, which is 300. So that's between 0 and 360. So I'm going to use 300 degrees because I like it better. Is that true? No, we don't care what you like. We care that's 5 pi over 3. So that's what you need to use. So, kind of care what you like, but not really, you know. You'll like degrees over radians because you can draw it up in degrees. But you're going to have to use radians anyway. So, it equals 5 pi over 3 plus what? 360 degrees N NEI, which I get on tests all the time and it makes me sad. Can we make radians with degrees and mix them up and like intermingle them? Should we still like, no. What do we have to add? 2 pi n. If you want to give it a little flair, do 2 n pi. There's your flair you can do. N is an element of the integers. Okay, C, D, E, F, go. E, we're going to use 4 pi over 3 as our principal angle because negative 2 pi over 3 is not between 0 and 360. So we're going to go theta equals 4 pi over 3. Make sure you use theta equals. So you need the angle equals 4 pi over 3 plus 2 pi n. N is now in the integers. D, your principal angle is 300 degrees. So we're going to go theta equals 300 degrees plus 360 degrees N. N is an element in the integers. E, the negative 135 is too small. If I add 360 to it, I get 225, right? So I'm going to use the 225. So I'm going to go theta equals 225 degrees plus 360 degrees and NEI. And the last one is 750. The angle that falls between 0 and 360 is 30, right? So we're going to do 30, theta equals 30 degrees plus 360 degrees and NEI. Now, can you please take out your formula sheets? Your formula sheets are your best friends for now and the next 3 minutes. So, this question gets asked to me all the time, so I want you to listen really, really closely. So once your formula sheets are out, I want you to put your hands down. Everything down. Hands up if you'd like. Nothing in your hands. Okay? All right. The question I get asked all the time is you call me over on a test and you say to me, does it need to be in radians or degrees? Does it need to be in radians or degrees? And I say to you, you should know. Or I say, it's not trig, it doesn't matter. But when does it matter? So, if this does not happen, radians and degrees doesn't matter. Okay, get ready. Everyone listening? Because if I get that question asked, I might send you to someone else. Okay? Like, be like, go talk to someone else, because I explained it really well. I won't. I'll just explain it to you again. But, you know, I'll try. Okay. Ready? The sign button, the coast button, the tan button are being pressed. One of them. If one of them is being pressed, radians and degrees matters. If any other button on this calculator is being pressed, it doesn't matter. Okay? So if I go like this, everyone paying attention? If I go y equals 4x cubed plus 7x squared plus 3x minus 2. It's a polynomial. Does it matter what radians or degrees I'm in? No. Did I press sine, cos, or tan? No. So what I would suggest to you, even second sine, second cos, second tan, that's a problem as well, because you're still pressing those buttons, right? So as if you're physically pressing the sine, cos, or tan button, or the second sine, second cos, or second tan button. So before I go to press it, if I'm like, oh, I'm going to type in cos 30, I'm going to go cos, and I'm like, halt. I can't press the cos button until I've decided if it needs to be in radians or degrees, right? If I go to press that button, I'm like, no, girl. What does it need to be in? So, if it's cos 30 degrees, what do you suppose it should be in? Degrees. Yes, thank you. Not pretty faces, not just pretty faces here. Brains. Okay. What if I give, get ready, tan of 3 pi over 4? Radians. Okay, this one gets people. Tan of 2.7. Radians. Tan of 2.7 with a degree symbol. Degrees. So if it has a degree symbol, it's degrees. And if it doesn't have a degree symbol, it's not just pretty faces. Okay, we're going to go talk about this now. So we're practicing our little rules I just gave you. So I need to type in sine 30 degrees. Everyone paying attention? Pick up your calculator. I have to go sine 30 degrees. I go to press the sine button and I do what? I say, not today. Don't touch it yet. What do I need to be in? 30 degrees. What do I need to be in? Degrees, because it says degrees. So I go to mode, and I make sure I go to degrees and hit enter. And then if you want out, you cannot press clear 7,000 times, which is what I see you guys doing. You can just go second mode. Second mode gets you out of that screen. Okay? And now you go sine 30, enter. People are like, where's the degree symbol? You don't need a degree symbol, you just put it in degree mode. No, you're not. We're going to do this for 3 units. You will not do this. Okay, enter. What do we get? 0.500, because it says to 3 decimal places. Okay, the next one I'm going to press cos, and I'm like, stop, girl. Pi over 6. What's that in? Radians. Radians. I go to mode. I'm like, I'm not pressing that yet. I got to go to radians. Then I go second quit, take myself out of the mode. And then I go cos pi divided by 6. So long gone are the days where your teacher resets your calculator and says, make sure you put it back in degree mode or you're going to get the whole thing wrong. It don't matter what mode you're in because you're going to have to switch it sometimes, right? So if I go cos pi over 6, I get 0.866. Ruh-roh, what is this CSC crapola? It's cosecant. Even if your brain doesn't know this because it hasn't been taught it yet, go to your formula sheet. So if I'm like, dude, I don't know how to type that in, there's no CSC button, there's a sine, a cos, and a tan. What are you doing to me? Go to the CSC. What does the formula say? It says cosecant of theta equals what? 1 over sine of theta. We agree? Is that on your formula sheet? C. Cosecant. It's the reciprocal side, which you'll learn from. So, if I have to type that in, I'm going to type in, instead of cosecant 1.57, I'm going to type in what? 1 over, and I'm going to make sure that I'm in what? Radian. Yeah.
What did you put a degree sign in for me, like that or something?
The moment you press the degree button, that is degrees.
So what did you get 0.56 degrees?
No, this is the answer. So when you do sine of 30 degrees, it's a coordinate on your unit circle. So sine of 30 degrees is the y coordinate at 30 degrees. So we're going to talk about the unit circle tomorrow. At 30 degrees, you have a unit circle that goes like this. At 30 degrees, your coordinate is root 3 over 2.5. This is the y. Sines are the y's of every unit circle coordinate. So it doesn't have a degree symbol because it's an actual just length and measure, unit measure. Okay. So we type in 1 divided by sine 1.57, and you get 1.000. Cotan on your formula sheet, cotangent. You could use cos over sine because you have both those buttons. Or if you look a little further down, cotangent equals 1 over tan theta. So cotangent theta equals 1 over 10. So it's easier to type it into your calculator that way. So cotan of 70 equals 1 over tan of 70 degrees. What do we need to be in?
Degrees.
Degrees. And so you get 0.364. Make sure you're in what? Degree mode. So if you're getting it wrong, you're probably in radian mode. How are you typing it in?
If you do cosine 70 divided by sine 70 and degree mode, you get, it's like,
Okay, are you closing your brackets? Are you closing your brackets?
Wait, do you have to go to
Yeah. So you always, whenever you press sine, cos, or tan, it's going to open a bracket on you. You need to close it. So Hannah, what you're probably doing is like cos, or you're probably going sine of 70 divided by cos of 70. So what it's doing is it's going sine of 70 divided by cos of 70 because you didn't close the bracket.
oh,
You know what I mean? Yeah. So it'll pop on open, you got to close the bracket behind it.
right.
All right. So I'm going to get everyone to grab one of these booklets. It's your homework for this chapter. So go grab one. 4.1 is the first page. There are 2 4s. I don't know why I did that. I apologize. You have 4 and then 4 again. 6 questions. That looks like 4.